Hello there, grade 10s. Welcome to the second lesson on Euclidean geometry. Right, so as I promised, today we will be doing we'll be dealing with triangles and polygons, right? So this might be a quite lengthy lesson. So as I said on the previous video, that even the grade 11s and 12s are mostly welcome to come back and revise this. So what does this mean for you guys in grade 10? Please make sure that you grasp this concept now, so that when you guys get to grade 11 and 12, you know that we are not going back to this, right? So please make sure that you fully understand, right? So let me quickly just get into the business of the day and let me not waste any more time, right? So we have actually four type of triangles, right? So no, let me say there are four types of triangle I want us to focus on today. There might be actually more than this, like obtuse angles and triangles with acute angles, So there's quite more than this here, but I want us to focus on this because they are mostly the ones that are important, right? So the first type of triangles, we have a type of triangles where all the sides are not equal. So what is that triangle or the type of triangle called? So that type of triangle is called a scalene triangle, right? So let me write that here. So this type of a triangle is called a scalene triangle, right? So please don't judge my writing here because from the position I'm writing in, right? Okay, so the important thing is for you to grasp the concept here. So here we have a type of triangle where all sides are not equal, not even one or two, right? So we call this type of triangle a scalene triangle. So we have a second type of a triangle where only two sides are equal. So you can see the moment we have these two symbols here that are the same, it simply means that they are equal. So it means that in this type of triangle here, they are all equal, right? So please grasp that. It's very important. You're going to see it more in your tests and classworks, all those things, right? So here we have a type of triangle where the only two sides are equal, right? Or the opposite, to be precise. So the opposite sides must be equal. And what does that mean? The moment we have two opposite sides being equal, we are then saying that we're gonna have the two base angles being equal, right? The opposite base angles being equal. So what is this type of a triangle? This type of a triangle is called an isosceles, right? So this is an isosceles triangle, right? So please make sure you know all this type of triangles all by head, right? They must be engraved in either your heart and mind. Anytime they ask you to state this, make sure that you are fully aware of what it is, right? So I'm moving on now from the isosceles triangle. It's a very important triangle. You're gonna be mostly tested on it. So please make sure that you grasp what is it about now, right? We're still gonna go deep into it when we go even on more content, right? So now let me quickly go into this type of a triangle here where we have this seat here which is called a 90-degree angle, right? So we have a type of triangle where we have a 90-degree angle, right? So what is that triangle called? So that triangle is called a right angled. So that is called a right-angled triangle, right? So because it has a right angle here, and we know that a right angle simply means equals to 90 degrees, right? So please don't be confused by that. And we know that it has a side opposite the 90-degree angle, which is called a hypotenuse, right? So please make note of this type of triangle here, never forget it, right? Moving on to the fourth type of triangle that we have here, where we have all the sides being equal and all the angles inside here being equals to 60 degrees, right? So what do we call this type of a triangle? We call it an equilateral triangle, right? I hope that this, guys, makes sense for you. Equi means equal, right? So it means equal in length. So all the sides in this triangle are equal in length, and all the angles are equal in length, in size, right? So now that simply gives us an equilateral triangle, right? So I know some of you guys might seem or look at this as something that maybe is wasting your time. Please note, this is very important from here going forth, right? So these are the 4 types of triangles that we have in Euclidean geometry, right? So now I want us to go to the properties, or what you are mostly required to know when it comes to triangles. Now, what are those things, right? So I want to quickly make a drawing here. So if you can be given this type of a situation here, right, this is maybe 1, this is okay, this is 2, that is 1, maybe we call this A, B, C, or let's say that is D, right? So the minute you have an extension here, so sometimes in a question you'll be told that D is extended or C is extended to D. So the minute you have an extension, you are required to look for what we call an exterior angle. So here we have an exterior angle. Right. Where is the exterior angle? This exterior angle here. So what do we know about this exterior angle? This exterior angle C1 will be equals to angle A inside here, which is this, plus angle B, which is this angle here, right? So please, this is very important to know. The minute we have a triangle and we have an extension here, we are required to know that there is an exterior angle which is equals to the 2 or the sum of the opposite interior angles, right? I hope that this makes sense. What is the second thing that we must know about a triangle, or the properties of a triangle? It's that the sum of the interior angles of a triangle are all equals to 180 degrees. So angle A plus angle B plus angle C2, which is this angle here, is equals to what? 180 degrees. And what is the reason? The sum of angles in a triangle, right? So I'm writing this in full and not in abbreviation so that I'm not losing you guys. Or when you're now used to abbreviation, you can say sum of angles in a triangle, right? That's as simple as how you can write it if you don't want to be writing it in longer notations, right? So what is this other important concept that we need to deal with when it comes to triangle, right? So most of you guys struggle with this concept, the concept of congruency and similarity, right? So please, guys, make sure that you open your ears even more now, because this concept that we want to deal with now, it's a very important concept, right? So now we want to deal with congruency and similarity. Now let us start off with congruency. What does congruency mean? So congruency simply means exactly the same. Right, so that is how I'd want you to understand this concept of congruency. Right, okay, so now how many conditions do we have when it comes to congruency? We have 4 conditions. So always know that when it comes to congruency, we have 4 conditions. Now, what is the first condition that we have for congruency? The first one is what? Side, side, side. So what does this side, side, side mean? It means that when we have 2 triangles, this is A, B, C, or maybe let me throw it with a separate color or a different color. Let's say this is E, F, G, right? So if we can maybe have something like this, let me change the color there, something like this, and maybe let me change the color for the third one, something like this, right? So what does this mean? So if we have 2 triangles and all the sides in each of the 2 triangles are equal, So that allows us to say that these triangles are congruent. Why? Because of the reason side, 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 or all the sides are equal in length. So for example, AB is equals to EF, AC is equals to EF, and BC is equals to EFG, right? Let me correct that. BC is equals to FG. Therefore, we can now say, or let me even write that. AB is equals to EF, right? BC is equals to FG, and EG is equals to what? Is equals to AC. So therefore, we can say that therefore triangle ABC is congruent. So now, people always confuse this. So how do you remember the sign for congruency? I said that is exactly the same. So you might think of it as an equal sign. So you can write this, but now it's an equal sign with a bar on top. So now this is congruent to EFG, right? So I hope that this concept here makes sense, guys. So you must prove that all sides in each of the two triangles are equal, and if all the sides are equal, you're allowed to say that they are congruent. Why? The reason is side, 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 right? Hope you guys are not confused. Let's go back, or let's continue with the second condition that we have for congruency. Now, the second condition happens when we have two triangles, right? So we have two triangles here. Okay, so what is happening in these two triangles? So in these two triangles here, we have an angle, right? We have a side, right? And we have another side, right? Okay, but there's this thing that I want you to note here. There must be a side or two sides that are equal and an included angle. Now, what is an included angle? It's an angle in between the two sides that are opposite, or that are opposite each other, yes. So you can see that in this one, we have a side equal to this one, we have a side equals to the other one, and we have an included angle, which means an angle in between, or an angle in the middle of these two sides, right? So immediately when we have that, if we were to say here A, B, C, right? Then maybe now we give this to be E, F, G. So that would mean that AB is equals to EF, AC is equals to EG, BC is equals to FG. Then if all of that is qualified, right? So no, I made a mistake here. Let me not confuse you guys. So first it's the sides. AB is equals to EF, right? Then we go on to say an included angle. Angle A is equals to angle E, right? Then lastly we say that angle BC, no, it's not BC. I don't know why I want this BC, but we're proving the last side, right? So that would be AC is equals to EG. And if that is true, therefore we are allowed to say, therefore triangle ABC is congruent to triangle what? EFG. Why? Because it's side, angle, side. Remember, write it in this case, and the angle must be in the between here to show that there is a side and an angle in between the two sides. So here we said that this was side, side, side. We've already written the reason here, right? So there's no need exactly, right? So I hope that I'm still with you guys, right? I know now it's getting a little bit tense and a little bit lengthy, but please hang in there, guys. If you don't understand, you pause to listen carefully and you go back so that no concept misses you out, because this is very crucial, guys, I tell you, right? So let me continue with the third condition. What is the third condition here? So the third condition is that we're gonna have a triangle. So remember, we're still dealing with triangles. We're still dealing with triangles. We're not losing the triangles. These are all related to triangles. So you can see that there's a lot of things that go with triangles, because ever since we started, it's just triangles, you know. So it means that you really need to grasp these things because they are very important. Otherwise, we wouldn't be even doing them. So we must have an angle, right? After having an angle, we must have another angle. After having another angle, we can have a side, right? So in this case, you just need to have two angles that are the same and one. So if I say this is A, B, C, right? And let me name that to be E, F, G, right? Okay, so what needs to happen here? You must have any two angles on one side being equal, right? So if you have that situation, therefore we say we have congruency, right? So in this case, angle A must be equals to angle E, angle B must be equals to angle F, and lastly, AB must be equals to what? FE, right? Or EF, it's up to us. Then now we say we have what? Angle, or we can say therefore triangle ABC is actually congruent to what? To triangle EFG. And what will be the reason? Angle, side, because we have two angles and one side, right? I hope that this, guys, is making sense to you, right? So immediately when we prove congruency, then we can assume that those two triangles are exactly the same, right? Okay, so hang in there as we do one last condition, right? So let me quickly just take this off, right? Okay, so I won't remove that one. Let me just continue from there to say this is condition 4. Then what is the last condition that we have? So the last condition is where we have this type of a triangle here, a very special type of a triangle, right? So we can have this here, we can have that. Let me just draw the other triangle here, right? So we must also have that here, and we must have that, right? Okay, so what must happen in this one here? So when we have two right-angled triangles like this here, so we are told that these two will be congruent if the hypotenuse and the side or one other side of each of them is equal, right, to the hypotenuse of the other one. And another thing, we must have this 90-degree here, right? Okay, so here we can just say if this was A, B, C, and this was E, F, G. So what we can say is that AB is equals to EF, and we can say that AC is equals to EG. Then finally we can say that, oh, B is equals to F, right? Which is also equals to 90 degrees. And what we can say from there is that, oh, therefore triangle ABC is actually congruent to EFG. And what will be the reason? Right hypotenuse side. I hope that this, guys, makes sense to you guys. So these are the 4 conditions for congruency, right? So I quickly, just before I close this, I wanted to make this and include the polygons, but I see this is going to be very long. So I'm just going to cut it on the congruency and the similarity. So allow me to do the last concept, which is similarity, because it's equally as important as congruency. And you guys are going to be tested in your grade 10 for this, right? So if you think you're going to run away from this, then I'm sorry, because you are going to find it in your exam, right? So please continue to stick to, right? Okay, so now let me come back now to similar triangles, right? So what are things that are similar? So when we talk about similar things, we talk about things that look alike, right? So they look alike, but they are not exactly the same. So we can have a situation where maybe we have two Coca-Cola bottles that you find that maybe the other one, it's a 330 milliliter can, right? And maybe the other one is a 440, which is quite longer, milliliter. They both branded the same and they look the same, but they are not actually the same, They're not actually the same or equal because they are different in length and size. So that is what we're looking at when we look at similar triangles. So we look at things that almost look alike, but they are not the same thing, right? Okay, so now let us get into the issue of triangles. So when it comes to triangles, we actually have two conditions, right? So other one deals with the corresponding proportion or the same proportion, and the other one deals with angles, right? So what we are told here is that, okay, let me quickly just do that. Right. So on the last one, let me have the purple one. Right. So on the issue of similarity, so we say that the first one we can use angles. So if we can say this is A, B, C, and this maybe it's E, F, G. You can even see with the sizes that this thing is not the same thing. They are similar, as I was explaining with the example. So if we can have A being equals to angle E, and we can have angle B being equals to angle F, and we can have angle G being equals to angle C. We can have angle C being equals to angle G, right? So we can assume that therefore triangle ABC is what? Is similar. So now similar, it's vertical 3 lines, right? It's similar to triangle EFG, and what will be your reason? Angle, 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 right? So we have this other one which is usually confused with the side from congruency. So in this case we look at the proportion. Now what is the proportion that we are looking at? So we are looking at similar sides or same proportion. Same proportion is actually the good word to use. So if we can look at AB over EF being equals to maybe BC over FG, and maybe DFAC being equals to EG. So you see they are in the same proportion. So here we say that AB over EF will be equals to AC over EG, which will be equals to BC over FG. Therefore, if this is true, we are allowed to say therefore A, B, C is what? Is congruent. Sorry, I wanted to write the congruent one. Is similar to what? Triangle EFG. And what will be your reason? Side, side, side. So this is the reason that mostly confuses people with the congruency one, because there's also a side, side, side for congruency, right? So, but this is just sides in proportion. Please, guys, do not confuse these two, right? So I'll just end here for this session before it becomes very, very long, and I don't want you guys to get too overwhelmed now. So after that, I will be dealing with polygons. What is happening in polygons? So that's where we'll be looking at parallelograms, rhombuses, kites, and all the likes, quadrilaterals to be precise, right? So please, guys, join me on the next lesson as we look into polygons. Then we'll now go straight to what you guys are required to do in grade 10. Thank you, guys. I hope that you guys enjoy this lesson, and please continue to share it with other people who are in need as well. If you are assisted, therefore many other people can be assisted. Right. Have a great day and enjoy your academics. Bye.